Okay, so in the next one, we need to see how we generate various random quantities like numbers and elements from a sequence using the Python random module. So this is a situation where you need to work with a module, in this case a built-in module, and basically find out how to use it to solve various tasks. And of course, if you knew what function to use from the module, this would be very easy. But in nearly all cases, you won't actually know exactly how to use the module. Like, what function am I supposed to use to solve the first task, generate a random number between 0 and 1. So I'll sort of approach it from the angle that maybe I'm not sure myself, and how do I actually find out the answer to those questions. So there are two ways of doing it. The first way is sort of the boring way, and that is to ask Google. You can actually take these questions, copy paste them into Google, and it's very likely that it'll figure something out. If Google cannot answer it, ChatGPT in almost all circumstances can. And that's of course a completely valid approach, but it's also a little bit boring and a little bit slow. And usually there is a faster way. So the faster way involves letting Visual Studio Code help you. So in order to do that, I'm going to generate a file. I'm going to call it scratch.py. And then I'm going to print something out, like let's say we print out PyWorld. Now I have a valid file, and that means that I can insert a breakpoint. And then I can start the debugger in the file. Okay, why am I doing that? I'm doing that because Python has, or Visual Studio Code has really good autocomplete. So if I import the random module and then do random dot, it tells me everything I can do with the random module. And as you can see here, there are quite a lot of options, but there are not that many options. You can actually skim these options, and then you can make a guess. Is it this one? Is it this one? Is it this one? Is it this one? Is this one? I think it's this one. Random, that sounds like a good option. So if I then complete the parentheses, and all I do here is that I just let it complete, write the first parenthesis, and then it'll give me additional hints. So in this case, it tells me it makes a float. It doesn't take any arguments. It makes a float. The float is in the interval 0 up to but not including 1. Fine, that's actually what I need. So now I can just test that this is actually correct by running the code that I've written so far. So I'm going to go to the debug console, I guess, and select this test and run it. Let me just print out what it generates. And now we can see that it generates random numbers like this. In order to run this line, I'm using the shorthand Shift Alt plus E that I used many times so far. But if that shorthand doesn't work on your computer because you're using a Mac, I think there is a hint on Piazza on how to do it. But alternatively, you can also just use the terminal down here, although it's a little bit slower. But somebody figured out what the corresponding shorthand is on Mac and posted it on Piazza. So I thought I should mention that. Okay, generate a random integer between 1 and 10. Well, how do I do that? I ask autocomplete, because let's see, is there something that looks familiar? There's something called randint. That sounds familiar. What arguments does it take? I'm just writing the parentheses, and then it says a and b, a random integer in the range a to b, including both endpoints. Fine, so that's just 1 and 10. And then I'm kind of done here. So I select this code, and I run it, and it works. In order to run the line again, I can just use the up arrow on the keyboard and then, of course, enter. So we see it is inclusive of the endpoint. It generates a 10 in this case. Okay. Generate two random integers between 5 and 10. Well, that's not hard. 5, 10, 1, 2. Okay, that's good enough. Sample 10 times from this thing with replacement. Okay, and with replacement means that the same number can be drawn multiple times. We can think about this list as a little set of elements, and then we pick up an element from the urn, and that might be 3, but since it's with replacement, we add the 3 back into the urn and then we draw a random element again. Okay, so how can we do that? Well, who knows, but maybe it knows. So we have one that's called choice and one that's called choices. Let's see what choices does. So choices takes a bunch of input arguments. So one called population, that might sound like what I want to take the choice of. And then it takes some weights, which can be none, and some cumulative weights, and they can also be none. And then it takes k, which is an integer, which is 1. Let's see what it does. Return a k-sized list of population elements chosen with replacement. If the relative weights are not specified, this selection is made with equal probability. Okay, so it sounds like it can select case elements. It returns it as a list, and the selection can be made with equal probability. Okay, or non-equal probability. We probably want equal. We want equal probability in this case. So the population was just 1, 2, 3, 4, 5, and then k should be equal to 1 to get one element. Let's try to run this code and see what it does. It gives us a list with element 5. Okay, so we need to actually index this list. So now I'm just indexing and choosing the first element, and that is going to give us a random integer selected from the list. So that's one way of doing that, solving that problem. I think I skipped one. Choose a random element from a list of strings. But that's simple, right? Now here we have a way of selecting random elements from a list of numbers. We can just put in a list of strings here. So cat, dog, koala, dragon. It still kind of works. So I didn't have to, haven't had to consult Google even once so far. Of course, it's not at all embarrassing to consult Google, or because often when you do that, you learn something else. But this is at least one way of doing it. Okay, so that was that one. And now we get to the hard one, I guess. Sample 10 times. Oh, we have to sample 10 times from this list. Can I do that like this? Okay, I don't know. I'm sorry, I didn't read the problem good enough, well enough, sorry. So let me try to keep these separate. So this is the one where we sample from a list of strings. And now when we have the list of integers, and we want to sample 10 times 1, 2, 3, 4, 5, we can just set k equal to 10. That's the number of elements we return. And then we just no longer select the first element of the list. And that will give us 10 random numbers like this. And they look reasonable. Okay, let's go to the last one. Sample 10 times from this list with probability being proportional to the number itself. And that's the problem. So 1 should occur much less frequently than 5. Okay, so in this case, we can let autocomplete help us a little, because autocomplete will tell us that it takes a weights variable, and the weights variable reflects how frequent we should select a given number. This might be a case where it's a good idea to actually consult Google a little and explore what this weights variable actually does. But it does allow us to encode the probability. So in other words, if I set the weights as probabilities, it's going to do the right thing. It's going to use it as a probability vector or a probability value for each of the elements when it performs the selection. So the way I would solve this problem would be this. I would take my list like this. I will still say k equal to 10, but now I set the weights, and I just use autocomplete here, to be equal to 1 divided by 15, 2 divided by 15, 3 divided by 15, 4 divided by 15 and 5 divided by 15. And then when I do that, it should be the case that, oh, I forgot a comma. It should be the case that 5 occurs far more frequently than it did before. So we see that that is indeed the case. It does seems like it's doing the right thing now. In fact, if you read up on the documentation and you need a little more information than what I've shown here, you'll actually realize that the weights don't need to be normalized. Python is going to make sure they are normalized as probabilities. So we could have solved the problem a little simpler just doing this. That would have accomplished the same thing. Anyway, that's how we can accomplish these probabilistic tasks. There's a last thing here where it asks us to fix the seed in this way and see what changes. So what's a seed? In Python, or basically any other in most programming language, I'd say, the random numbers are actually generated with an algorithm, and I think in case of Python, it's something called a Mersenne twister. It doesn't matter what that does, but what it means is that the random numbers are in fact not truly random. They're generated algorithmically using a complicated algorithm that takes an integer as an input argument. So if we reset that integer every time we generate a random number, it'll always generate the same sequence of random numbers. And we can do that using random.c. So let me just illustrate how that works. If I call random.c to 42, and this can be any integer. So instead of 42, we can do 99. And I call this line. Then if I do random.random, it's going to output this number. Now if I call it again, it's going to output a new random number. But now if I go back and call this reset function again, like set the seed again, it'll in fact output the same two random numbers. So this can make a program that depends on random number behave the same way every time by simply repeating the same sequence of internal random numbers. So that's just good to be aware of, it's something that can be helpful if you have a random algorithm that you want to debug, and you want to make sure that it therefore behaves in the same way between runs. Okay, I think that's all I have to say about this problem, and then we'll move on to editing actual Python files. Of course, that's kind of what I've been doing here, but this has just been my way of doing it. Okay,